In question number one, figure shows a battery having some EMF and a heater is there having its resistance of 6 ohm. State what is meant by EMF. This definition I'm not taking, children. That definition, what do you mean by EMF of a cell or a battery? Amount of energy required to make a charge to flow in an electric circuit. So in B1, calculate the current in the heater. Yes, Krisha, calculate the current in the heater. What equation you will apply? You need to calculate how much current is flowing in this circuit diagram across this heater. Krisha,
Yes.
how much current? What equation you will apply? When the voltage is given, resistance is given, you have to calculate.
Voltage divided by resistance.
Ashmit Rawat.
Sir, V by I.
I equal to V over R. Okay, what about if I use equation P equal to VI? Is power given in the statement? No, power is not given. So if P equal to VI, I can't. So better to apply, just use the direct Ohm's law equation. V is equal to IR. So then you can calculate.
Yeah, sir. So basically taking R to the other side. So V divided by R will give you I.
Yeah. The second part, state the name of the particles that flow through the heater. What particles move?
Electron.
Yes, for this part, this answer will be electrons flow. You can write electron like this or electrons. Next question, on figure 8.1, draw an arrow next to the heater to show the direction of flow of these particles through the heater. Where will you draw a sign of arrow for the direction of electron? Children, Astha Lalwani, Astha, the sign of arrow for the movement of electrons will be clockwise or anti-clockwise direction. Astha. Astha said clockwise direction. Okay, children, that the electrons move from the negative, they start from the negative terminal. So this is the way to represent the direction of electron. You can write here, electrons are going in this side. And so what path, this you can say this is a clockwise direction, or even you can draw a sign of arrow to show. Nickel, it's not anti-clockwise, it's a clockwise direction.
Clockwise direction.
Next question, children. Calculate the thermal energy produced in the heater in 10 minutes. Thermal energy or heat generated, heat produced in the heater in 10 minutes. What equation you will apply? Sorry, what equation you will apply here in this question to calculate the heat generated by the heater if heater is operated for 10 minutes? Sorry.
E is equal to VIT.
Yes, very good. E is equal to voltage multiplied by current multiplied by time. Voltage is given in the statement, 12-volt battery. How much current is flowing? What is the answer of first part, children?
So current was
We calculated voltage was 12 and the resistance is 6. So this
6.
2 ampere current is flowing. Okay. And the time is here 10 minutes, should be converted into seconds multiplied by 60.
600.
And whatever the answer, that will be the heat generated into joule. You multiply, and then next question, children. In D part, combined resistance of two resistors are there. Sorry, combined resistance of the two resistors are given, and this is 4 ohm. Calculate the resistance R. So first time we are doing this type of question, children. You need to calculate R when one of the resistance is given and the total resistance is given. So let me do this question, children. Even you can also do it, and you can send your answer in chat box. I know that both the resistance 6 ohm resistor and this unknown resistance, they are connected in parallel. So I will use the equation to calculate the total resistance in parallel, that is R1 multiplied by R2 and divided by the sum of both the resistors. RP is given, that is 4. You write here 4 equal to R1. Suppose this is 6. R2, that is R, divided by 6 plus R. Now in the next step, children, you have to cross multiply. 6 plus R equal to 6R here. Be careful, children. Sometimes some students only they multiply this 4 with 6. They forget to multiply R also with 4. So 2 6 are 24 plus 4R equal to 6R. Then you have to use algebra mathematical equation. 6R minus 4R equal to 24. And then finally this R equal to 24 divided by 2, which is equal
12.
to. So this is the answer. 12 ohm is the answer of this question. That this unknown resistance R is of value having 12 ohm. Input output power we are not doing. Question number 4, children. State the relation between R and L. How they are related. Sidong. May I know the relation? Are they directly proportional or inversely proportional? In question number 4A, first part. Sidong. Jarvis. Sidong and Jarvis.
So is it directly proportional?
Yes, they are directly proportional to length. And what about in the second part, R and cross-sectional area? May I know the answer?
Inversely proportional.
Yeah, they are inversely proportional. So how to write inversely proportional? You can write in a sentence form that R is inversely proportional to area, or even you can write in this way. Both answer will be considered correct. R is directly proportional to 1 by A or inversely proportional to area. Yeah, Harshan, R equal to 1 by A, correct. Instead of writing equal, better is R is inversely proportional sign you can use, because when you write equal, then the final equation in terms of equal sign, that R is equal to resistivity length divided by area.
Sir, I couldn't type that because I don't know the symbol.
Okay, good, Harshan. Okay, no problem. So in question number B, 4B, a 60-watt filament lamp X is connected to a power supply having voltage 230 given in the diagram. Calculate the current flowing in the filament. In the question number 1, we have done a heater was connected, but this time they have given certain value. We have done it now, but with a filament having a power is given. So if power is given, I have to calculate current, and now resistance is not there. So better to apply equation power is equal to voltage times current. If you use this equation, 60 divided by voltage, how much voltage is 230 there, and then in the right hand side it will be current. So 6 divided by 23, children, you can divide this, so that will be the answer in ampere. Yes.
So the answer is 0.26.
You're saying so the I is equal to 0.26 ampere. So you need to divide 6 by 23, children. Don't leave it in exam 6 by 23. Better to simplify it and then write the answer. Okay, Jarvis, good. 0.26. But in exam, don't forget to write the unit also. It's 0.26 ampere. So after finding this, remember that 0.26 is the current. And in 4C, lamp Y has a filament made of the same metal as the filament of lamp X in B. This filament has half the length, means the lamp Y has length half of the lamp X. And what about the area of cross section? 1/3. Lamp Y is also connected to the same voltage, that is 230 volt. Calculate the ratio of current in Y to the current in filament of X and show your working, children. You have to find the ratio. It's not about just only writing the answer. You have to show your working. Take some moment for this question, children. Take your time and then please type your answer. This question can be solved again with the different methods, but whatever the method you use, answer should come same in each and every case. Who will explain this question? Ankit Sharma. Mohammad Keenan. Mohammad Keenan, can you hear me?
Yes, sir.
Could you explain this 4C? Anirudh?
Sir, I'm calculating.
Meher?
Yeah, I'm still doing.
You can do this question with the help of an equation. R1 equal to rho L divided by area. And for resistor 1, I can take length L1. For area of cross section, A1. Similarly, for the resistance R2, this equation is rho. L2 is the length of second wire and A2 is the area of cross section of the second one. Now, children, that as both the materials are made of the same, both the wires are made of the same material, resistivity will be same. You can equate this equation and you can write here R1 multiplied by area divided by L1 equal to R2 area 2 divided by length 2. So now apply this equation. Now, children, you are thinking about, so where is the current? How will you find out that the value of current? So current equation is not included in this, but you know, R is given by voltage divided by current. Voltage divided by current. So again, in the next step, you can replace this R1 with the voltage and current here I1. I1 means I will take this IX, okay? And area A1, that is for the AX now, is equal to resistance of second, voltage. Now, why I'm taking this, I'm not taking Vx and Vy because the voltage are same. This is 230 and they are going to cancel. So Vx upon Iy multiplied by the area of the cross section of the second wire. Now V will be cancelled out here. Sorry, L1 will be here and L2 will be here. V is cancelled. both sides this will be cancelled. Now you have to simplify. Put all values here. AX I will keep same. IX ratio I have to calculate, I will keep IX same. L1 I'm not going to change. I will do the changes in the second case. What about the area of second filament, children? And where it is written that the area is 1/3 of the first one. So it means I can write AY, the mathematics children, this AY is equal to 1/3 of the area of cross section of the first wire or the first filament. So you replace AY by AX divided by 3. In the denominator, you have to write IY as it is, this IY here. What about the length of the second? L2, this means L2 means this LY. What information is given for the length of second wire? The second wire length is half of the first one. So L2 can be replaced by, this is the multiply sign. L2 will be replaced by L1, half of the L1, so 2 will be here. Now AX cancelled by AX, children. L1 you can cancel by L1. If you find out, yes, Anirudh?
So won't it be L1 over 2?
Where L1 over 2? Yeah, that is the L1
So
over 2.
because
Yeah, L1 over 2. So the 2 I have written into the numerator side. When you write L1 divided by 2, so the 2 will go to the upside.
okay, sir.
Okay, yeah. So basically it is L1 by 2. So the 2 will be, I have written in the numerator. So finally I got answer IY ratio of Y divided by X, that is equal to 2 by 3. Is there any doubt, children, in this question? And if you find any other method, you can also apply, but the answer should be ratio of current in Y to the X, it should be 2 by 3. Meher, is this clear? This question, Ashmit, Meher?
Yes, sir.
Yes, sir.
Please remember these steps. Remember these steps. Now, next question. Question number 5. A piece of wire has resistance. Calculate the resistance of another piece of wire of the same material with 1/3 of the length and half the cross section. Now, please, children, do this question by yourself, as this question is also based upon the same equation which we have used in question number 4. So take your time, do it, please. Listen, how will you do this question? Again, you have to apply the same equation. Let me write the equation that R1 multiplied by area and the length of the first wire equal to R2 A2 divided by L2. So I will consider that this is our first wire having resistance 0.45. So 0.45 I will write here 45 divided by 100. I replace the decimal point. What about the area A1? I will take it as it is, and its values are not given. Length I will take, that is not given, so I will consider the length of the wire. They are talking about L1. What about the R2? We have to calculate this R2. In the second area of cross section, they said calculate the resistance of another piece of wire with the same material and with 1/3 of the length and half of the cross section area. Half of the cross section area means that this A2 is half of the A1. That is the meaning. Half of the A1. So you can write A2, that is equal to A1 by 2. Now in the denominator, you have to write L2. What is L2? They said length of the second wire is 1/3 of the length of the first wire. And we have taken length of the first wire L1. So it will be L1 by 3. So L1 by 3. So I think I can write 3 here. Now please do the A1 cancel by A1. You can cancel L1. And what we have left with, okay, now you need to cross multiply. And if you cross multiply this, R2 is equal to 45 by 100 multiplied by this 2 will be this side here, and this 3 will come to the 100 side. 45 2s are 90. 100 into 3, whatever you do, you can use calculator, children, in exam. 3 by 10. I got
Oh,
3
yes.
by 10. So 3 by 10 means this you can write 0.3 ohm. This is the resistance. What about?
Oh, wait.
Did you get the same answer?
Yeah, sir, now I did. Now I did.
Those who want to note it down, children, you may note it down. Let's move to the next question. 5b. There is a circuit diagram, 3 resistors, a power supply, and 4 voltmeters are there. V1, V2, V3, V4. Okay. Then what we have to do in this question, calculate the combined resistance of the 3 resistor. Calculate the combined resistance. Please take some time in this question. 3 resistors are there. Look at this diagram carefully. Look at this diagram carefully, children. And find out the total resistance of this combination. One resistor here, second is here, and the third resistance is here. Also, those students who are unable to do this question, listen carefully how to find out the total resistance in this combination. Children, that in such type of questions, better that you start from the power supply, and power supply, that suppose you have to just assume that the current produced by the battery is I1. This current I1 is going. When it moved to this point, junction point, some current, this side I2 is going along this side, and this side some of the current moved to this side, and then I3 current is passing through the 3 ohm resistor. I2 and combining with I3 and making a current of I4, that I4 current is passing through the 2 ohm resistor. So basically the current is dividing among 1 ohm resistor and 3 ohm resistor. So I will consider that this 1 ohm and 3 ohm resistor, they are in parallel. So if they are in parallel combination, I know how to calculate the resistance, which is 1 into 3 divided by 1 plus 3. So this is 3 by 4 ohm. So 3 by 4 ohm is the resistance of this combination. First, I have calculated this resistance. Now in the next case, children, what you can do, replace this both of the resistance, and in rough work you can draw another resistance whose value we have calculated, which is 3 by 4. Forget about that, this resistance is not here. But for that, I have taken one resistance whose value is 3 by 4. So this resistance 3 by 4 and this resistance 2 ohm, you can see they are in now series combination. Whatever the current coming from I2 and I3, that current will pass through that I4, and the same current will pass through the 2 ohm resistor. Now they are in series combination, and I know the equation for series. This will be 3 by 4 plus 2. So if you do the calculation, you will get 4 to the 8.
I got
11 by
11 by 4.
Yeah, 11 by 4 is the overall resistance of this entire circuit diagram, children. So this is the way to do this question, children. Again, start from the battery positive. Battery has produced some current. Follow this path, and then you have to simplify this one. There is one answer here in chat box. Let me see. Harshan said it's 11 by 4. Yes, it's 11 by 4. Andrew said 11 by 4. The next part of this question we will do in the remaining time, children. In the second part, write down the two relation for the current in the circuit. Okay, let me end this meeting first, children, and we will continue with this question.
Okay, sir.